Think for a second about the sheer improbability of your own hands. The fact that you can feel the texture of the chair you're sitting in or the warmth of a cup of coffee. We often go through our days assuming that the world around us is just there, that the stars above and the atoms below are just inevitable parts of a cold mechanical reality. But if you peer into the blueprints of the universe, you start to notice something unsettling. The cosmos doesn't look like a random accident. It looks like a series of miracles that were narrowly avoided by a hair's breadth. Every fundamental force, every orbital path, and even the very existence of matter itself seems to be balancing on a razor's edge. If any one of these things were just a fraction of a percent different, the story of the universe would have ended before it even began. There would be no stars, no planets, and certainly no one here to ask why. Tonight, we're going to look at 10 cosmic coincidences that seem too perfect to be random. Maybe it's just luck. Or maybe, as we'll see, it's something much stranger. 10. The moon's impossible geometry. Let's start with something you can see for yourself. Look up at the night sky, and you'll see the moon, a silver disk that's been our constant companion for billions of years. We take it for granted, but the moon harbors a mathematical alignment so precise it borders on the surreal. The sun is a colossal fusion reactor, roughly 400 times larger in diameter than our moon. By all logic, the sun should dominate the sky, while the moon should look like a tiny, insignificant speck. However, by a staggering coincidence, the sun also happens to be situated exactly 400 times further away from our planet than the moon is. This specific ratio, 400 to 1 in both size and distance, creates a breathtaking optical illusion. From our vantage point on Earth, the two most important celestial bodies in our sky appear to be the exact same size. This isn't just a pretty sight for a postcard. This configuration allows for a perfect total solar eclipse, where the moon slides precisely over the solar disk, blocking the blinding photosphere but revealing the sun's delicate corona. This specific alignment was the key that unlocked our understanding of the universe. It allowed Sir Arthur Eddington in 1919 to photograph the bending of starlight, proving Albert Einstein's theory of general relativity. In a universe full of planetary systems, Earth is the only world we know of that has observers capable of questioning the cosmos and a satellite system perfectly tuned to help them find the answers. It almost feels like the universe was tailored for discovery. 9. Jupiter. The silent sentinel. If the moon is our guide, Jupiter is our bodyguard. For life to evolve from single-celled organisms into complex, conscious beings, a planet needs a long, uninterrupted stretch of peace, billions of years without a civilization-ending impact. But the early solar system was a violent shooting gallery, filled with rogue planetesimals and comets crossing the inner planetary orbits. Enter Jupiter, the gas giant. It is a behemoth, possessing more than twice the mass of all the other planets in our solar system combined. This immense bulk creates a gravitational well so deep that it acts like a colossal cosmic vacuum cleaner. Its orbital path sweeps the outer edges of our system, catching, absorbing, or violently deflecting incoming cometary bodies before they can plunge toward Earth. We saw this in action in 1994 when the Shoemaker-Levy 9 comet slammed into Jupiter. 9 comet slammed into Jupiter. It was a multi-fragment strike that would have sterilized our homeworld if it had hit us instead. Without this planetary bodyguard standing watch, the quiet epochs necessary for our evolution would have been routinely shattered by extinction-level events. We owe our existence to a distant, turbulent sphere of gas that just happens to be in the right place to protect us. 8. The magnetic Goldilocks zone beneath your feet. Thousands of miles down, there is a churning ocean of molten iron and nickel. This geodynamo generates a planetary magnetic field that acts as an invisible fortress against the hostility of space. But it's not just the existence of the field that matters, it's the meticulously balanced intensity of it. A planetary magnetic field is a delicate mechanism. If it were too weak, like on Mars, the relentless solar wind would strip away our atmosphere, turning our watery world into a desiccated, irradiated wasteland. Conversely, if it were too strong, like on Jupiter, it would trap charged particles and radiation belts so intense they would instantly sterilize terrestrial life. Earth sits perfectly balanced on this tightrope. Our field is robust enough to deflect destructive solar storms and prevent our atmosphere from being blown into the void, yet it remains weak enough that it doesn't create lethal radiation traps in our orbital space. This specific threshold of shielding allowed delicate biological molecules to form and evolve without being perpetually sterilized by cosmic radiation. We inhabit a narrow sanctuary protected by an iron heart that beats with exactly the right amount of force. Point 7. The cosmic accounting mistake. To understand the most improbable coincidence of all, we have to rewind to the absolute beginning, a fraction of a second after the Big Bang. In that violent, hyper-dense crucible, energy condensed into the building blocks of reality. Physical laws dictate a strict symmetry. For every particle of matter created, an identical twin of antimatter should have been cast alongside it. When matter and antimatter meet, they annihilate each other with perfect efficiency, turning back into pure light. Under the strict rules of physics, the early universe should have functioned as a self-erasing equation. The equal parts of creation should have canceled each other out, leaving behind nothing but a cold, featureless void of drifting photons. But a statistical anomaly occurred, an aberration so slight it defies comprehension. For every 1 billion particles of antimatter, there emerged exactly 1,000,000,001 particles of regular matter. This tiny, infinitesimal discrepancy acted as the tiebreaker in the ultimate cosmic war. As the Great Annihilation ended, all the antimatter was extinguished, and what remained was that fractional leftover margin of regular matter. Every galaxy, every star, and every living cell is constructed exclusively from this tiny mathematical rounding error. We are the survivors of a cosmic accounting mistake. Point 6. The triple alpha process. Once you have matter, you need the right kind of atoms to build life. The absolute foundation of biology is carbon. But the creation of carbon deep inside stars relies on a mechanism so precarious it almost didn't happen. To build heavier elements, stars must fuse helium. The intuitive step would be to crash 2 helium nuclei together to form beryllium-8. But beryllium-8 is notoriously unstable. The moment it forms, it decays back into helium in a fraction of a second. To bridge this gap, a third helium nucleus must strike the beryllium-8 before it disintegrates. This is the triple alpha process, and statistically, it is highly improbable. However, carbon exists because of a highly specific quantum resonance, a hidden mathematical bridge that perfectly aligns the energy levels of the nuclei, allowing this fusion to happen at a rapid pace. Astronomer Fred Hoyle predicted this exact resonance in the 1950s, realizing that if this microscopic target weren't hit with unfathomable precision, the cosmos would be a sterile cloud of hydrogen and helium. There would be no planets, no oceans, and no us. The fundamental constants of nuclear physics are arranged as a precise Locant-Key mechanism explicitly to allow for the elements of life. 5. The proton-to-electron mass ratio. If we look at the architecture of the atoms themselves, we find another foundational pillar that seems suspiciously tuned. Atoms are composed of a dense nucleus of protons surrounded by a cloud of electrons. The relationship between these components is governed by a rigid constant, the mass ratio between the proton and the electron. In our reality, a proton is precisely 1836, 15 times more massive than an electron. If you were to sit at a cosmic control panel and shift this ratio by even a fraction of a percent, the molecular fabric of reality would unravel. If the electron were slightly heavier or the proton slightly lighter, the delicate balance of atomic orbitals would be thrown into chaos. Electrons would spiral into the nucleus or fly off into space, and the rules of chemistry would dissolve. The complex folding chains of proteins and the double helix of DNA require highly specific, stable atomic interactions that are completely dependent on this 1836, 15 constant. Without this precision, the universe would remain a sterile soup of disconnected particles, incapable of building anything more complex than a lone atom. 4. The strong nuclear force. Deep within the atom, there is a hidden tension that dictates the stability of our world. The nucleus is packed with protons, which all carry a positive charge. According to the laws of electromagnetism, like charges should repel each other violently, the protons should fly apart, tearing every atom to shreds. The only thing preventing this subatomic catastrophe is the strong nuclear force, the invisible glue that binds the nucleus together. But the strength of this force is a precisely dialed constant with a sliver of tolerance. If the strong nuclear force were just 2% stronger, protons would bind together far too easily. Stars would burn through their fuel exponentially faster, exhausting themselves in seconds rather than billions of years. the night sky would be brief and dark. Conversely, if the force were just 2% weaker, it couldn't overcome the repulsion between protons. Heavier nuclei couldn't hold together. The universe would be restricted to a menu of simple hydrogen, no iron, no oxygen, no nitrogen. We are suspended between a reality that burns out instantly and one that can never build a world. 3. The flatness of the universe. Cosmologists use a parameter called omega to measure the total density of the universe. This single value determines whether the universe will eventually collapse in a big crunch or expand so rapidly that stars can never form. For the cosmos to support complex structures, omega must be exactly 1, a state known as a flat universe. This is a mathematical razor's edge. When physicists calculate the required density at the moment of the Big Bang, the numbers become dizzying. For omega to be roughly 1 today, the initial density of the early universe had to be fine-tuned to an accuracy of 1 part in 10 to the 60th power. To visualize that level of precision, imagine firing a rifle at a 1-inch target located on the opposite side of the observable universe and hitting the dead center. If the initial density had varied by the mass of a single atom, the fragile equilibrium would have been shattered. We exist because the explosive force of the Big Bang and the inward pull of gravity were matched with a level of exactitude that continues to baffle the greatest minds in astrophysics. 2. The vacuum catastrophe, the cosmological constant. We now arrive at what many call the most embarrassing failure and the most staggering coincidence in the history of science. It involves the cosmological constant, or the energy of empty space itself. Quantum physics tells us that empty space isn't actually empty, it crackles with a latent energy. When theorists calculate how strong this energy should be, the result is colossal. It should be so powerful that it would instantly tear apart galaxies, solar systems, and atoms. Yet, when we look at the actual universe, the value we measure is infinitesimally small. The difference between what our best math predicts and what we actually see is 120 orders of magnitude of 1 followed by 120 zeros. This is the tightest constraint in all of science. To allow a structured universe to exist, the value of this dark energy must be fine-tuned to 1 part in 10 to the 120th. It presents an ultimate dilemma. Is this miraculous tuning the result of a vast multiverse where we just happen to win the lottery? Or is there a fundamental lottery? Or is there a fundamental law we simply don't understand yet? 1. The unreasonable perfection. Finally, we have to look at the big picture. When you peel back the layers of the universe, you find a control panel with about 26 fundamental constants. These are the dials of reality: the speed of light, the mass of an electron, the strength of gravity. There is no theoretical reason why these numbers are what they are. They are just brute facts of nature. But if you were to take any one of these dials and turn it just a hair's breadth in either direction, life and the universe as we know it would cease to exist. The precision required for our existence is equivalent to throwing a dart from Earth and hitting a bullseye on the edge of the observable universe. This is what physicists call the fin-tuning problem, or the unreasonable perfection. Why is our universe so perfectly calibrated for our existence? Is it a cosmic coincidence of absurd proportions? Does it imply we are part of an infinite multiverse where every combination of laws exists, and we just happen to grow in the one microscopic crack where the math didn't instantly crush us? Or does it suggest something more unsettling, that the parameters of our reality were deliberately engineered? Outro. The music swells slightly, then becomes very sparse. The narrator's voice becomes a bit more personal. Science has no answer for this yet. We just live inside this razor-thin margin of mathematical improbability, staring into the dark and wondering how we got so incredibly lucky. We are fleeting observers standing on a pale blue dot, gazing into an expanse ruled by invisible forces. But the very fact that we can look up, measure these shadows, and calculate the final moments of reality is a staggering testament to human curiosity. The universe may be dark and impossibly vast, but for this brief, beautiful cosmic moment, it has produced a species brave enough to stare directly into the abyss and demand to know why. Maybe we are a statistical miracle, or maybe the universe was waiting for someone to notice the patterns. If you enjoyed this journey into the architecture of the cosmos, consider subscribing. And next time you look at the moon or feel the weight of a stone in your hand, remember you are a part of a story that, by all accounts, never should have happened. Until next time.